This video is about limit at infinity. What happened if you want to take a limit at x approaches infinity of some functions? All right. So for an example, the first example I want to talk about is let's say if you have a power function, the limit as x approaches infinity of let's say x to the third, right? So you know that for the function x to the third, the graph looks something like this, right? So in this problem, it's asking what happened to your function if x approaches infinity, meaning x getting bigger and bigger, right? So if as x approaches infinity, as x getting larger and larger, f of x, x to the third going to get larger and larger, right? Much faster than x itself. So in this case, you can say that it's going to approach infinity, right? So if you want to double check yourself, you can put in a really large number for x. Let's say, 1,000. Then 1,000 cubed is going to be a very large number, right? So for this problem, how about, so that's easy when you have a power function, right? So for a power function, that's simple. How about when you have a rational function, right? So let's look at what happened if we want to take a limit of a rational function. So a rational function, right? So let's look at an example here. Let's say the limit as x approaches infinity of x squared plus 3x minus 2 divided by x to the third plus x squared 3x squared. Let's do it that way, right? So in this case, it's really tough to really, you could factor it now and see if anything canceling, right? Or you could think, all right, so what do I know that will help me? So let's say if before we start this problem, you can ask yourself, what if I take a limit at x approaches infinity of 1 over x, right? Then in this case, if you put in a very large number for x, that means that 1 over a very large number, then that means that this one is approaches 0, right? So, or you can think of it as using a graph. Look at your graph here. The graph of 1 over x will look something like this. So, right? So if x approaches infinity, mean the x approaches very large number, notice that your function here is approaches 0, right? Right? Does that make sense? Let me better draw in the function. So it's approaching 0. Right? So that is why we can find the limit of x approaches infinity of 1 over x is 0. Okay, so we're going to use this fact and that's going to help us solve for this one. So now I'm going to go through and divide the top and the bottom by the highest power of the denominator, which in our case is going to be x to the third. So I'm going to say I'm going to divide top and bottom by x to the third. All right, and then let's see what it's given us. The limit of x approaches infinity of x squared divided by x to the third plus 3x divided by x to the third minus 2 divided by x to the third. That's the numerator, and the denominator you have x to the third divided by x to the third plus 3x squared divided by x to the third, right? So now that simplified it out a lot, right? Let's limit of x approaches infinity. So this fractions right here, you only have 1 over x here plus this fraction right here is 3 over x squared. and minus 2 over x cubed. That's divided by 1 plus 3 over x, right? So now you by the definition of limit of a sum is the sum of a limit. So you can distribute this limit into each of these fractions, right? So you know that the limit of x approaches infinity of 1 over x is 0, right? So therefore this term is go to 0. Now 3 over x squared is going to go to 0, right? Because if I put in x is 1,000, x squared is 1,000 squared. 1 over 1,000 squared is going to be approximately 0, right? And that solves this one because x squared is smaller than x cubed, right? And then this term is also go to 0. So in the numerator, I have 0. And the bottom I got 1. So this limit is go to 0. So for rational functions, you want to divide it by the highest power of the denominator to see whether your limit exists or not. Now, some people can pay attention. So if the denominator, the highest power of the denominator is larger than the numerator, then the limit goes to 0. But if the highest power of the denominator is smaller than the numerator, then the limit is go to infinity. And if the denominator and the numerator that have the same highest power, then the limit is go to the coefficients of the highest power of the numerator and denominator. Right? I hope you get that. So let's, for an example, if I have a limit of x approaches infinity, I'm going to do x cubed plus 2 divided by x squared, right? So if we're using the same method, we're going to divide the highest power of the denominator to divide x squared, right? Then in this one, we're simplifying to limit of x approaches infinity. Of the top will be x cubed divided by x squared plus 2 divided by x squared divided by 1, right? And that is just x plus, that is just equal to the limit of x approaches infinity of x plus 2 over x squared over 1, right? And you know that this limit is 0 and this limit is 1. And so therefore, limit of x approaches infinity of x is infinity. So that means, so here you have the denominator smaller than the numerator. So therefore the limit goes to infinity. Here you got the denominator is larger than the numerator, the limit goes to 0, right? And now the third case, when you have a limit, let's say of the denominator and the numerator is equal to have the same highest power, let's say 2x squared plus 1 over 3x cubed. Oh, sorry, same highest square plus 2x, right? So now we're going to do the same method that we just talking about, divided by the highest power of the denominator, right? So that will give us equal to the limit of x approaches infinity. Of the top, we will have 2x squared divided by x squared. That will give us a 2 plus 1 divided by x squared. And then the bottom, 3x squared divided by x squared, that gives us a 3. And then 2x divided by x squared will be 2 divided by x, right? So now you can see that this term goes to 0. And this term goes to 0. So therefore, the limit is equal to the leading coefficients of the highest power, right, which is 2 over 3. All right, so I hope it helped.